Section 8.1 Sequences and Arithmetic Sequence. Back in elementary school, sequences are taught in a way they are just a list of numbers. Back in elementary school. Here we define them differently. So before we define them, I prepared the notes in advance on the tablet so we can go through this in a better way. So what is the definition here in college algebra class? The definition of a sequence, we define it as a function whose domain is the set of positive integers. And what are the positive integers? Are those that start at 1. So 1, 2, 3, 4, those are the positive integers. And to write down a sequence, there are several notations. Some people write a sub n, let's say 2n, or you can write it f of n, 2n. If n is not specified, automatically means n bigger than or equal to 1. So it means n is 1, 2, 3, 4. For each value for n, we get a term for the sequence. So we get, if you substitute n1 here, you get 2. If you substitute 2, 2 times 2, 4, 3, you get 6, 8, and so on. Those are called the terms of the sequence. Terms of the sequence. Note that a1, when I substitute n1, that gives me 2. a2, that's the second term, 4. The third term, a3, is 6. a4 is 8. These are the 4 terms of this sequence. We can look at some other example. Find all terms of the sequence an equals n squared plus n minus 1 for n between 1 and 3. That's why they said all of them, because they put a restriction on n. This means n starts at 1 and it's run to 3. So 1, 2, 3. So we're going to find when n is 1, we're going to get a1. It's 1 squared plus 1 minus 1. These cancel, the answer is 1. For n equals 2, we're going to get a sub 2 is 2 squared plus 2 minus 1. 4 plus 2, 6 minus 1, 5. A sub 3 is 3 squared plus 3 minus 1. 9 plus 2, 11. So these are the terms of the sequence, the 3 terms. So when they said all of them, these are all of them. So the 3 terms are 1, 5, and 11. Let's look at another one. Find the first 3 terms of the sequence. Notice there's no restriction on n, and they only want the first 3 terms. This means when n is 1, n is 2, n is 3. That's what it is. N is not specified, so n starts at 1. So we're going to take n equals 1 and substitute it in, which is not difficult to do so. So it's negative 1 to 1 plus 1 times 3 to the first over 1. So that gives us negative 1 squared times 3 over 1. Negative 1 squared is 1 times 3, 3 over 1, 3. That's a1. a2 is negative 1 to the 2 plus 1 times 3 squared over 2. That's a negative 1 times 9 over 2, or negative 9 halves. Next one, a sub 3 is negative 1 to the 4th power times 3 to the 3rd over 3. That's a 1 times 3 to the 3rd over 3. 27 over 3 is 9. So the negative 9 over 2, you can leave it like this, or you can write it in decimal form. Either one is fine. Now we introduce what we call factorials. Factorials are those that where we use the exclamation mark. So 3 factorial, so 3 exclamation mark, is 3 times 2 times 1. So you multiply that number by all the numbers right below it all the way until you reach 1. So 3 times 2 times 1 is 6. 2 factorial is 2 times 1, which is 2. So 1 factorial is 1, and by definition 0 factorial is also going to be 1. In general, n factorial is n times n minus 1 times n minus 2, so it's 1 less, all the way to 2 times 1, as you can see. So now find the first 3 terms of this sequence. You see how the factorial sign is involved. So to find that, we start with n equals 1 and substitute, not difficult. So negative 1 to 1 plus 1 over 1 factorial. So negative 1 squared over 1 factorial. And 1 factorial is 1, so you get 1 over 1, which is 1. A sub 2, you substitute n2, 2 plus 1 for the exponent, over 2 factorial. That gives us negative 1 half. And then if you try you try n equals 3 before you're looking at the work, and try it, pause the video, try, and see what you get. Well, when you finish, you're going to get 1 over 6. So keep in mind, negative 1 to any odd number is negative 1. Negative 1 to any even power is 1. Next one, find the first three terms of the infinite sequence in which a1 is given. A1, they give us a1 already. And then they give us an, which is a function in an minus 1, or in terms of an minus 1. This is a specific kind of sequence. We call it the recursive sequence, recursive. So the next term will depend on the previous one. So first thing, notice how n is bigger than or equal to 2. So I can start by taking n equals 2 first. N equals 2. So if I take n equals 2, substitute it into this formula here. So what do we get? We get 3 sub a1 plus 5. But a1 is given 2, so we're going to substitute that in. 3 times 2 plus 5. 6 plus 5, 11. That's when n equals 2. What about when n is 3? When n is 3, you get a sub 3 equals 3 sub a sub 2 plus 5. But a sub 2 is 11. So 3 times 11 plus 5, 33 plus 5, 38. So therefore, they give us a1, we found a2 and a3, and they want the first three terms. And those are the first three terms. Now, this was just an introduction to sequence. What is a sequence? And what are the terms of the sequence? Or now what we need to do is to talk about one of the kinds of sequences, really special kind, and most useful, is one called arithmetic sequences. Arithmetic sequence is the one where it follows a pattern where you add the same number every time. That number could be positive or negative. So arithmetic is the one that you keep adding the same number every time. So as an example to this, 5, 8, 11, 14, 17, 20. Do you see every time they're adding 3? So that's called an arithmetic sequence. And I'm going to abbreviate it with AS, arithmetic sequence. So this is just a specific example. So now, what does is there a formula that arithmetic sequence follows? Well, we can do that now. A1, if we start with A1, I'm going to prove the formula. It's A1. That's where start. A2 is going to depend on A1 and add a number. So add the same number. Call it D. A3 is going to be A2 plus add another D becomes 2D. And then A4 is going to be A3 plus 3D. So notice, in general, the nth term, AN, is always going to be, sorry, this is A1. A1 plus. Notice how when we had a 4, there was a 3. When was a 3, there was a 2. Was a 2, there was a 1. And there was a 1, there was a 0 there. There's nothing. So it's always 1 less. So that's why, since this was n, this is n minus 1, where n is the number of terms here, as you can see. So this formula is the general formula for an arithmetic sequence. General formula for arithmetic sequence. So let's look at an example on this. Let's say we have this kind of sequence that I wrote earlier, and I want to generate a formula, like the boxed one, that generates or find a formula that generates these terms. And how do you do this? Well, 5 is A1. I need A1 and D. D is the number that you add every time. We call it usually common difference. So A1 is 5. D, what is the number they're adding every time? It's 3. So it's going to be, based on the formula, I substitute A1 5 and D 3. And you can leave it like this, but it would be nice if you can multiply this in, distribute it to simplify. So AN is 5 plus 3n minus 3. So that gives us AN is 3n plus 2. So that would be the formula for the nth term. So this will generate all the terms for us. If you like to test it out, see the fifth term here is 17, right? If you substitute n5 for the fifth term, 5 times 3, 15, plus 2, 17. 17. So that gives us the general formula for the arithmetic sequence. Now, how does that help us? So if they ask us find the 1000th term. So imagine if you want to go back to the top of this page and start substituting or adding 3 every time. Adding 3, another 3, another 3, that will take forever to finish with this. So to do this, what we can do, all you have to do substitute n equals 1000 into the formula we obtained in this box formula. So that becomes 3 times 1000 plus 2. That's 3002. See how easy this becomes? Like I don't have to go back and add 3 every time 1000 times. That will take forever. So the formula made it easier for us. So note, this is the sequence. In this sequence, if you take any of the numbers say 8 minus the previous, or 11 minus 8, 14 minus 11, 17 minus 14. All of these always will give us the same number, which is 3. Is called the common difference. And it's common because it's common among all the terms, and difference because of the subtraction. So that's how we, in general, we find that number. So they give you a number and you want to, a list of numbers, and you want to find if it's arithmetic sequence. You want to test if this same number being added to the sequence. How do we find the common difference for the nth term of a given sequence? Let's say they give us this an. They want us to find common difference, which is d, right? So if you write down the main formula, which is an equals a1 plus n minus 1 times d, and compare them, you see the highlighted ones, that's what d is. D is 5. If you're asked for the first term, a1, it would be -7. But we're not asked. We're asked just to find the common difference, d. So the common difference, d. So d is 5 and a1 -7. What about something like this? An equals -2 and minus 8. How do you find the common difference? Well, let's say you don't know what to do. If you don't know where it is, you can start taking n equals 1, n equals 2, n equals 3, and then find the pattern in here. Find the pattern. So that's what I did. I took n equals 1, substituted in. I got -10. For n equals 2, I got -12, -14, so on and so forth. And I notice every time we are subtracting 2. So that's what d is. D is the -2, the common difference. That's what d is. Every time we're adding the same one, the same number, which is -2. Now, they can make it a little bit more challenging. They ask us, find the 7th term. So the 7th term means a sub 7. What is that? Of the sequence that has a first term a1, a1 -3, and the common difference d is 4. So these are all the information they give us. They give us d is 4, a1 -3. They want us to find a7. When they talk about common difference, automatically means it's an arithmetic sequence. And the first thing I always write down is the formula. So that's the given, that's the formula. They want us to find a sub 7. So I'm going to substitute here n7, and it goes the same thing there. D is 4, so I'm going to substitute d4, and a1 is given -3. So it's a matter now of substitution. So -3 plus 7 minus 1 times 4. 6 times 4 is 24, minus 3 is 21. That's a1. That's a1. Another example. Write a recursive formula for each of the following sequences. I think that's one of them. 5, 9, 13, 17, 21. So notice, recursive means you're going to start with a1. a1 is 5. And then find an in terms of a sub n minus 1. So a1 is 5. And remember the formula an. What happens here is we are adding every time 4. 4, 4, 4. So it's kind of like you take the nth minus 1 term and add 4 to it. And that's what we got there. So it's going to be always an equals an minus 1 plus or minus some number in case of arithmetic sequences. So note that always when we have arithmetic sequences, we write it like this. If you have this, if you want to continue with this, this is called the nth minus 1th term. This is the nth term, and so on and so forth. Next one, we have two examples, 30, 25, 20, 15. Notice they're subtracting 5 every time. They're subtracting 5 every time, right? So now how do we get to write the recursive rule? A1 is 30, so we start with A1 on the left side, 30, and we need AN. AN is going to be AN minus 1. They are subtracting 5 every time, as I mentioned. The next one, A1 is 4. What happened here? What did they do? This actually is not an arithmetic sequence. If you subtract, it doesn't work out. It's plus, minus, plus, minus. This means they are multiplying by something every time. Oh, they're multiplying by -1/4. If you multiply by -1/4, again -1/4, again -1/4, you get these numbers. So it's -1/4 times the previous term, an minus 1. Good to see it, although it's not arithmetic sequence, but good to see it. And we're going to talk more about later this. What about something like this one? T squared, t to the 4th, t to the 8th, t to the 16. So a1 is t squared. A1 is t squared. And a sub n is what happened, what they're doing every time. They're taking the previous one and they multiply it by t squared. No, if you multiply by t squared, you got t to the 4th, but then t to the 6th. So like t squared, t to the 4th, t to the 6th. It doesn't work out. What can be another way to do this one or think about this one? What they're multiplying by every time? Well, this is a little bit tricky. So no matter what you multiply by or add by, it's not going to work out. But what they actually did, from here to here, it seems like if you square this, you get the next one. If I square this, 2 times 4 is 8. If I square this 2 times 8 is 16. So it seems like you're taking any of the terms and square it. That will give you the next term that we're looking for. So this is just find the pattern basically here, but in a recursive rule or in a recursive form. This is just to help you to do some kind of critical thinking. That's what the sequences are about. Like this section was an introduction to sequences, and then we also talked about arithmetic sequences.